Hello, and welcome to the Strike and Dip tutorial guide video. Today I will be walking you through all of the elements that are included in the current iteration of the Strike and Dip project, which would be version 2.3.10. In today's video, I will start by walking you through all of the buttons and functionality included in the heads-up display. The heads-up display would be all of the objects that you currently see on your screen whenever you run the project. The first element of the heads-up display that I will be covering today will be the compass tool. The compass tool is the primary object you see here in the center of the screen, and it is made up of a couple specific components. The first component is the compass body. The compass body is the square part of the compass that you can see right in the center of the screen at the moment, a gray sort of rectangle. The next element of the compass tool is the compass face. The compass face is the circle that you see close to the center of the compass body. This compass face displays the cardinal direction symbols for north, east, south, and west, as well as the varying degrees for 0 to 360 that cover the entire range of the compass. The next element of the compass tool are the compass needles. There are two compass needles present on the compass tool. The first, being the primary or the north needle, is the white and red needle that extends all the way across the compass face. This needle will always point north no matter how you move or rotate the compass. The second compass needle is a smaller black needle that only extends halfway across the compass face, starting from the center of the compass face and reaching out to its edge. This would be the ground needle. The ground needle always points towards the ground. This ground needle can be used whenever taking the dip measurement. The next element of the compass tool that we'll be covering is the direction arrow. The direction arrow is the large gray arrow you can see attached to the bottom side of the compass that is directly pointing north towards the top of the screen. This arrow will indicate the direction that the compass is currently facing. It will also indicate the direction that a measurement will be taken whenever a strike or dip measurement is saved using the compass tool. The next element that we'll be highlighting is the hand outline. This outline is currently represented on the screen as a bright blue model of a hand that is placed underneath the compass. This is a model of a right hand and is used to display a concept frequently used in geology called the right hand rule. When taking strike and dip measurements with a compass in the field, in order to use the right hand rule, the user would place their right hand flat on the face of the outcrop that they would like to measure. They will place it so that their fingers point down the slope, or the dip in this case, and their thumb points to the left across the face, which indicates the strike. The next element of the heads-up display that I will be covering is the UI compass face. This UI compass face is a large copy of the compass face that is located in the upper right-hand corner of the screen. This larger version of the compass face will directly mirror everything represented on the compass face of the compass tool. This means that anytime you rotate the compass tool around the environment, the needles on this UI compass face will rotate to match the direction of the needles on the actual compass tool. This UI compass face also allows the user to rotate the face of the compass tool. In order to do that, the user can simply click on the UI compass face, and as they hold the button down and move their cursor, the UI compass face will rotate to follow the cursor, always having the north indicator on the UI compass face point towards the mouse. You'll see as you rotate the UI compass face the face of the actual compass tool will rotate accordingly. The next element of the heads-up display that I will be covering is the compass control panel. This panel appears in the lower left corner of the screen and is what will allow the user to manipulate the compass tool around the environment. The first element of this compass control panel that I will be covering is the rotate compass dial. This dial is the large circular button-looking object that is at the upper center of the control panel. This dial allows you to rotate the compass tool. In order to rotate the compass tool using the rotate compass dial, simply click on the rotate compass dial, and while holding the mouse button down, as you move the mouse, the dial will spin to continue pointing towards the mouse and will rotate the compass tool accordingly. The next element of the compass control panel that I will be covering are the position sliders. These position sliders are the horizontal bars on the lower half of the compass control panel. These sliders allow the user to move the position of the compass tool relative to the camera within the scene. There are 3 of these position sliders, one for forward and back, one for up and down, and one for left and right. As you can see here, as the user clicks on the knob in the very center of the slider, and while holding the mouse button down, moves the position of the knob along the slider, it will alter the position of the compass. The next element of the control panel that I will be covering are the reset buttons. These reset buttons allow the user to reset the compass tool's position or rotation to its initial starting position and rotation relative to the camera. In order to utilize these buttons, simply click on the corresponding button. To reset the compass's rotation, click once on the Reset Compass Rotation button. To reset the compass's position, click on the Reset Compass Position button. The next elements of the compass control panel I will be covering are the toggle buttons. These 2 buttons allow you to toggle on and off different elements of the compass tool. The first of these buttons is the toggle preview arrow button. Clicking this button allows you to turn on or off the direction arrow, the large gray arrow, attached to the underside of the compass tool. The next button is the toggle hand outline button. Clicking this button allows you to toggle on or off the outline of a hand that is attached to the bottom side of the compass tool. The next element of the heads-up display that I will be covering is the data window. This window can be found in the upper left-hand corner of the screen. This data window is the place that will represent all of the measurement data that is taken around the environment within this project. Each time the user saves a strike and/or dip measurement, those measurement values will be displayed on the data window. The data window is broken up into individual rows called data nodes. As you can see here, each data node, or row on the data window, has a node number indicating which data node it is associated with. Each data node has a value for the strike measurement, a value for the dip measurement, and a data node button. The data node button is the small circular button on the left-hand side of the data node. These buttons allow the user to switch between data nodes in order to take measurements for specific nodes, or in order to display the saved data within those nodes. As you can see here, out of the data node buttons, most of them are highlighted with a gray circle around them. One of them has a green circle around it. Whichever data node button has the green circle around it indicates that it is the active data node. Whenever the user takes a strike and dip measurement, it will be saved into whichever node is currently the active data node. The next portion of the data window is the smaller box that is towards the left center of the screen. This box will display the data buttons. These buttons are what allow the user to actually save data after they've positioned the compass. The first of these data buttons is a button that will be labeled Save Strike or Save Dip. The label on this button will change according to the current context of the measurement process. Before any measurements have been made, the button will read Save Strike, as the user will be taking a strike measurement before taking a dip measurement in any set of these measurements. Once the user has saved a strike measurement, the label for the button will switch to stating Save Dip. The other data buttons that show up in this area are a button labeled Draw Data, a button labeled Clear Drawn, and a button labeled Clear All. The Draw Data button allows the user to draw arrows along the measurement vectors for the strike and dip measurements of any given node. In order to draw these arrows, simply click on the Draw Data button. These buttons will not show up until a set of strike and dip measurements have been saved to that data node. Once these arrows have been drawn, if the user would like to clear them from the screen, they can simply click the Clear Drawn button, and this will clear the arrows for the currently active data node. If the user has multiple arrows drawn for multiple data nodes and would like to clear them all at once, they can click the Clear All button. This will clear all of the data arrows from the screen from each one of the data nodes in the data window. The next element of the heads-up display that I will be covering is the Main Menu and Main Menu button. To access the main menu, the user can click the Main Menu button, which is located at the very bottom center of the screen. Once this button is clicked, the main menu will open and will give the user access to a couple of submenus. These submenus are the Info Guide menu, the Level Select menu, the Options menu, the Credits menu, and an exit button that will return them to the normal gameplay. The first of these submenus I will cover is the Info Guide menu. The Info Guide menu will open up an overlay that sits on top of all of the objects on the screen and will give the user information about what each object is and what it does. By hovering the mouse over any object on the screen, a small information box will pop up explaining what that object is and how the user can use it or what it does. When the user is finished reading through any of these info guides, they can click the button in the center of the screen labeled Return to Main Menu. The next submenu I will cover is the Level Select menu. This menu is not available in all versions of the strike and dip tool, but for applicable versions that have multiple levels, this menu will open up displaying a small picture for each level that the user can access. Hovering over any given picture will open up a small information box stating the name of the level and giving a brief description of what the level is. In order to activate or switch to any alternative levels, simply click on the icon of that level in the Level Select guide. Doing so will load the corresponding level. The next submenu I will be covering is the Options menu. This menu allows the user to alter a couple of different preference items within the project. The first of these being the movement speed. This movement speed slider allows the user to change how quickly the camera moves around the environment when the arrow keys are hit. Moving the slider up, the user move faster. Moving the slider down will make them move slower. The second of these objects is the mouse look sensitivity, which controls how quickly the camera will rotate when the user holds down the right mouse button and moves the mouse. Doing so will rotate the camera to face in a different direction corresponding to the movement of the mouse. The next option is the data input mode. There are two primary data input modes, the first being autofill mode, which is the default mode for this program. In this mode, when the user saves a strike and dip measurement, the values corresponding to the compass's orientation are automatically calculated and filled into the corresponding locations on the data node representing the strike and the dip values. The secondary data input mode is manual input mode. In manual input mode, the user can click on input boxes for the strike and dip values for each data node. Once clicking on one of these input boxes, the user can then type in the value that they observe for the corresponding measurement using the compass tool and the UI compass face. By clicking one of the two buttons for these data modes in the options menu, the user can switch back and forth between which input mode they would like. In some versions of this tool, one mode will primarily be active, and these options will not appear. The last option in the option menu allows the user to toggle on or off the hand model attached to the bottom of the compass. This functionality is identical to the toggle hand outline button on the compass control panel. The next submenu I will cover is the credits menu. Although small, this credits menu displays information for the primary development team of this project. It also displays a few of the links to the primary contributors' Sketchfab websites, where we retrieved most of the models that are used within this program. This menu also contains two buttons on the left-hand side, which will take the user to corresponding websites associated with the Center for Immersive Experiences at Penn State, which is the center that is developing this tool. The next element of the heads-up display that I will be covering is the visibility display. This visibility display panel can be accessed using the button labeled Visibility Display that is close to the center at the bottom of the screen, just to the right of the main menu. Clicking this button will open up the visibility panel. This panel has buttons that allow the user to toggle on or off the visibility of most of the heads-up display elements. Clicking the Show All button will make all of the heads-up display elements visible. Clicking the Hide All button will hide most of the heads-up display elements. Clicking the Data Window button will toggle on or off the visibility of the data window. Clicking the Heads-Up Display Compass button will toggle on or off the visibility of the UI compass face. Clicking the Compass Control Panel button will toggle on or off the visibility of the compass control panel. Clicking the Compass Tool button will toggle on or off the visibility of the compass tool. Clicking the Minimap button will toggle on or off the visibility of the minimap. Clicking the World Map button will open up the full screen version of the world map. In order to close this world map, click the Close Map button at the bottom of the screen. The next element of the heads-up display I will be covering is the Tour Guide button and Tour Guide menu. The Tour Guide button can be found near the lower center of the screen, just to the right of the visibility display. Clicking this button will open up the Tour Guide panel. This Tour Guide panel has a couple of buttons that allow the user to teleport to different locations around the level. This panel also contains a display box, which shows the name of the current tour stop, as well as relevant information which corresponds to that tour stop. The user can teleport to preset tour stops around the level using these buttons. In order to teleport to the previous tour stop, the user can click the Previous Stop button. In order to teleport to the next tour stop along the tour, the user can click the Next Stop button. If the user would like to return to the very starting point of the level, they can click the Return to Start button. And if the user teleports to a tour stop and manually moves to a different location using the arrow keys, but would then like to return to the tour stop they most recently visited, they can click the Return to Current button, which will teleport them back to whichever tour stop they visited most recently. The next elements of the heads-up display I will be covering are the Raise Camera and Lower Camera buttons. These buttons can be found in the lower right-hand corner of the screen. These buttons allow the user to raise or lower the position of the camera within the scene. In order to raise the height of the camera, the user can click the Raise Camera button a number of times. In order to lower the position of the camera, the user can click the Lower Camera button a number of times. The next element of the heads-up display that I will be covering is the minimap. The minimap can be found on the right-hand side of the screen in the very center. This minimap displays a small overhead view of the level that the user is currently in. This minimap also has markers displaying the location of the user within the level, as well as markers for each one of the tour stops around the level. The marker indicating the player's position is a small red circle, which also has a black arrow. This black arrow indicates the direction that the user is currently facing. As you can see, as the user rotates their view or turns, the small black arrow will rotate accordingly. The purple markers on this screen indicate the locations of tour stops around the level. As the user teleports from stop to stop, you'll notice that the player icon relocates to be in the same positions, or relatively close positions, to the tour stop markers on the minimap. The minimap also will display small markers indicating the locations of any strike and dip measurement the user has taken. These strike and dip symbols are represented as small versions of an uppercase T. This symbol is reminiscent of the symbol used in geology mapping to indicate a strike and dip measurement marked on a field map. Anytime the user takes a strike or dip measurement within this project, a corresponding strike and dip symbol will show up on the minimap as well as on the world map. These symbols will rotate to correspond correctly to the direction of the strike and dip measurement relative to the level and relative to north within the minimap. The next element I will be discussing is the world map. The world map can be accessed by clicking on the minimap. Doing so will open a larger full-screen version of an overhead view of the map of the current level that the user is in. In the upper left-hand corner of this map, the user can see a small box that contains input option fields. Each one of these fields corresponds to a specific rock group that is represented around the field map levels. With these input fields, the user can click on any one of the input fields and then type in the name of the rock that they think corresponds with that rock group. These input fields also correspond to the drop-down menus for the map markers that you can see placed around the field map on the world map. Each one of these map markers corresponds to a field map station somewhere around the actual level. By clicking on any of these map markers, a drop-down menu will appear, which displays all of the rock group options that the user has typed into the input fields on the upper left. Once the user has selected one of these rock group types, you'll notice that the map marker changes colors to correspond to the color of that rock group. This color change is also represented in the cube that is placed at the corresponding field map station. Each of these field map stations around the level displays a couple of different elements, and we'll cover these elements a little bit more at a later point in the video when we go more in detail about field maps and what they are. The next aspect of the strike and dip tool that I will be covering is movement. Movement allows the user to reposition the camera around the level in order to ready themselves to take strike and dip measurements at various locations. The user can move the camera's position by pressing the arrow keys. These will allow the user to move forward and backwards using the up and down arrows, or left and right using the left and right arrows. The speed at which movement occurs when the user presses these arrows can be altered by accessing the options menu within the main menu, and at the top of the options menu is a slider that controls movement speed. If the user feels that their camera is moving too quickly or too slowly when they hold down the arrow keys, accessing this portion of the options menu will allow them to alter that to a more comfortable level by increasing or decreasing the movement speed of the camera. The next aspect of movement I will be covering is the mouse look feature. This feature allows the user to change the angle of the camera and look around the environment. In order to perform a mouse look, hold down the right mouse button and drag the mouse cursor around the screen. The camera will rotate to follow the cursor while the right mouse button is held down. This will allow the user to look left and right, up and down, without having to change the actual position of the camera using the arrow keys. The speed at which this mouse look occurs can be altered using the mouse look sensitivity option within the options menu. If the user feels the mouse look is too fast or too slow, they can alter this using the mouse look sensitivity slider. Moving the slider down will make the mouse look much slower. Moving this slider up will make the mouse look much faster. The next aspect of movement that I will be covering is the tour guide function. This function allows the user to teleport to different locations around the level that have been preset. In order to move to the next tour stop along the tour, the user can click the Next Stop button. In order to move to previous stops along the tour, the user can click the Previous Stop button. In order to return to the original starting point for the level, the user can click the Return to Start button. And if the user teleports to a tour stop, then uses the arrow keys to move, but would like to return to that tour stop, they can click the Return to Current button. The next aspect of the strike and dip tool that I will be covering is the process of taking strike and dip measurements. In order to take a strike and dip measurement, first the user needs to move to a location in which they would like to measure the strike and dip of a slope. On field map levels, this can be achieved by teleporting to one of the field map stations using the tour guide teleport functions. Once the user has arrived at a field map station that they would like to measure, they can position the camera closer to the slope by using the arrow keys to move the entire camera. Once they're relatively close to the slope, they can refine the position of the compass tool using the compass control panel. By changing the sliders on the panel, they can bring the compass tool as close to the surface as possible to get as accurate a measurement as they can. Once the user has positioned the compass close to the slope they would like to measure, they can use the rotate compass dial to spin the compass tool, orienting the compass so that it sits across the face of the slope. Once they have the compass positioned correctly across the slope, they can click the Save Strike button, which will save the strike measurement for that slope. The compass then will change to the dip mode, which, as you can see, flips the compass vertically. While the compass is in dip mode, the user can also use the arrow keys to rotate the camera around the compass without losing the compass as the focus within the center of the screen. When the user has positioned themselves in a way that they feel they're ready to take the dip measurement, they once again use the rotate compass dial in order to spin the compass tool so that it lines up with the downward slope of the face they're trying to measure. When the compass matches this slope, clicking the Save Dip button will save the dip measurement relative to the orientation of the compass tool. Once the user has saved the dip measurement, you can see that the strike and dip values for the measurements they've just taken appear within the currently active data node in the upper left on the data window. At this point, the user can click the Draw Data button to see arrow representations of the measurements they've just taken. The next aspect of the strike and dip tool I will be covering are levels known as field maps. Field maps give the user a place to practice strike and dip measurements, as well as practice their ability to observe the environment and collate both observations and strike and dip measurements together to form a larger picture of what the map of an area may look like underneath the surface. Positioned around field maps are individual locations known as field map stations. These stations are locations which the user can teleport to take specific measurements of strike and dip. Each of these field map stations has three primary components: the station number, the slope cube, and the hand sample. The station number indicates which number this field station is relative to both the tour stop guide and the world map. The slope cube is the large gray slanted cube that is displayed at the station. This cube indicates the face or the surface which the user is supposed to use to measure strike and dip values from that location. The last element, the hand sample, can be viewed at the top of the slope cube and is a small representation of the rock type that would be present at that location on a map. Field map stations look a little bit different depending on which difficulty mode the user is in. In beginner difficulty mode, field map stations will look as they do here, containing the field map number, the slope cube, and a small hand sample at the top. In the advanced difficulty setting, field map stations look more like they do here. In this version, no slope cube is visible, and instead of a small hand sample model at the top, the entire station has been converted into a large 3D model of a rock outcrop representing the rock type that is displayed at that location. This second version of field stations are a little bit more difficult to take strike and dip measurements from, but also give the user a more realistic experience of what taking strike and dip measurements from outcrops of actual rock would be like in the field. As the user travels to each one of these field map stations, not only will they save a strike and dip measurement from this station, they will also observe either the hand sample or the outcrop model at the station itself to try to discern what type of rock is represented at that location on the map. Once the user has observed the rock type for any given location, they can open up the world map, and using the boxes in the top left-hand corner, they can input the name of the rock type they observe into each one of these group fields. Once the user has entered the name of a rock type into these fields, the user can then click on the map marker corresponding to that field map station and assign that field station one of the rock groups that they have input. Assigning a field station to a rock group will not only change the map marker color on the world map to correspond to the color of that rock group, this will also alter the color of the slope cube at the corresponding field map station. Doing this allows the user to gain a larger perspective of what areas of the map contain which rock groups, and ultimately allows them to start painting a larger picture of what the geology of the area is comprised of.